So good morning to one and all. So next I'm going to discuss about the limits and fits. So the aim of the session is to familiarize the students with the concept of limits and fits, and the instructional objectives of this session are: the session is designed to understand about the concept of limits and fits, understand different types of fits, and describe about the difference between hole and shaft basis systems. And the learning outcomes to be expected from the students at the end of the session will be: they can able to define various types of fits, they can able to summarize various terminologies used, and they can able to find the limit sizes of hole and shaft. These are the outcomes expected from the students. So first I'm going to discuss about some of the important terms and definitions in subject point of view. The first one is shaft. The shaft term refers not only to the diameter of a circular shaft but to any external dimension of a component. You see, for example, if AC meter shaft, this is external dimension, that refers about the shaft. Hole. The term hole refers not only to the diameter of a circular hole but to any internal dimension of the part, internal dimension, that represents hole. Nominal size. The term nominal size refers to the size of a part specified in the drawing for the convenience of the shop floor. Okay, the size of a part specified in the drawing, that will be called as a nominal size. Basic size. The term basic size refers to the size from which the limits of a size derived by the application of tolerance with the help of upper and lower deviations. The basic size or the nominal size of a part is often the same, but it is termed as the zero line. For any part, the basic size is very important, which is also termed as a zero line. Limits of size. The term limits of a size refer to two extreme permissible sizes for the dimension of a part, between which the actual size should lie. Generally, you take any particular part which is having two permissible sizes are there, two extreme permissible sizes, where the largest permissible size for a dimension will be called as upper or higher or maximum limit, whereas the smallest size will be called as lower or minimum limit. Like that, for any dimension of a part, you take any part for which two extreme possible sizes, extreme permissible possible sizes will be there. Those two permissible sizes will be called as the largest one will be called as upper limit, a lower one is called minimum or lower limit. Maximum limit of a size. The term maximum limit of a size refers to the maximum or greatest permissible size of a feature or of a particular part, and a minimum limit refers to a minimum or smallest permissible size of a given part. Now the important one, allowance. The term allowance refers to the difference between the basic dimensions of two different mating parts. The allowance may be either positive or negative. For example, in the positive allowance, the shaft size is generally less than the hole size. In the negative allowance, the shaft size is greater than the hole size. Tolerance. The term tolerance refers to the difference between upper limit and the lower limit of a dimension, or which is also difference between a maximum limit and a minimum limit of a dimension of given part. That difference will give you the tolerance. Now coming to the fits, generally we'll use fits, FITS, in different assembly conditions. While assembling two mating parts, generally these fits will come into the picture. So fits are generally assembly conditions between hole and shaft. Okay, for example, if you take two parts like hole and shaft, let us see what are various conditions we'll get between these two, and with this fits only we can able to understand how tight or how loose the two components are connected. It's a kind of a relationship between the two components. For example, you see the two components, hole and shaft. Okay, whenever a hole is inserted into a shaft, if the clearance is minimum, then a thin oil film we can able to maintain in between the hole and shaft contact, and also the hole can able to slide freely into a particular shaft with a minimum clearance. And whenever the clearance is nil, then the hole the shaft can't able to move freely. Okay, to move the shaft we need to apply some extra pressure or force we can able to apply. That is not required. When you have to apply this, whenever there is no minimum clearance. At the same time, whenever there is more clearance existing in between the hole and shaft, then the shaft is going to be vibrated, so that the wear and tear problems will come into the picture. So finally what we have to do is, whenever the two components like hole and shaft are connected, okay, we should maintain permissible clearance and interference, so that the hole and shaft can able to operate efficiently and we can able to get the required output exactly from that. And also, whenever a part and various other components are looking to be designed, the engineering fits are taken as the geometrical dimensions, where the clearance between the two mating parts depends upon the requirement of size of the clearance. It depends, it is not fixed always. Let us see what are different types of fits are there, and also I'll give examples for each type of fit also here. First, the clearance fit. I am showing one figure here. You can able to see the clearance fit means always whenever the shaft diameter is less than the hole diameter, you can able to see some clearance here. This is minimum clearance, this is maximum clearance. The type of fit is called clearance fit. Shaft diameter is lesser than the hole diameter. Here hole diameter is large and shaft diameter is less. The hole is larger than the shaft. Okay, the shaft diameter is less, enabling the two parts to slide. See, when you use this clearance fit, what happened here, you see some clearance, minimum clearance is there, with which the shaft can able to slide or rotate into the hole after assembly. Examples in pistons, valves, will observe the same. You know, the piston is designed to reciprocate inside a cylinder head. Okay, with the clearance only, the piston can able to move freely, and also the valves, you see the inlet and exhaust opening valves, whenever if you give the clearance, then only those can able to slide or move. Whenever there is no clearance fit, definitely the piston or the valves, they can't able to move freely, they can't able to slide. Interference fit. You see, interference, the shaft diameter is larger than the hole. Here the hole is smaller than the shaft. In these cases, high force or heat is required to assemble or disassemble. Examples are bearing bushes. Generally bearing bushes, if you observe, the hole size will be smaller than the shaft diameter will be more here. We'll use a high force or any heat process to assemble or disassemble. And the last fit is transition fit. In transition fit, you see, here also the hole size is large, but the difference is the hole is fractionally smaller than the shaft, and a mild force only here it is required to assemble or disassemble. Let me tell you the difference between interference and transition fits. In interference fits also the hole is smaller than the shaft, but where high force or heat is required to assemble or disassemble, and here in transition fit the hole is fractionally smaller than the shaft and mild force is only required here. And the examples are shaft, key. Okay. Next, coming to the hole basis system, I'll show you a figure. Hole basis system means in the hole basis system always the size of the hole is kept constant. You see, for example, so this line is a zero line. This line is zero line. Okay, and this is called, you see it's mentioned already, hole tolerance. Okay, in the hole basis system the size of the hole is constant. Here I am showing you three different fits. The first one is clearance fit, this is transition fit, this is the last third one, interference fit. Is just see, this is a zero line. Here the size of the hole is constant and three different fits, clearance, transition and interference, are obtained by varying the size of the shaft. You see the shaft tolerance, we are varying the shaft from the basic line. This is clearance, this is interference, and you see this is transition. In the hole based system, by keeping the hole as a constant, we are getting three different fits. How? By varying the shaft. Now the next one is shaft basis system, in which the size of the shaft is kept constant and different fits are obtained by varying the size of a hole. It's a vice versa of the previous one. Here also you can able to see a zero line here. So this is shaft, shaft, shaft. Here the size of the shaft is kept constant and three different fits, clearance, transition, interference. Three different fits are obtained by changing or varying the size of the hole. You see, this is clearance, transition, interference. Okay. So like that we have a hole and shaft basis systems are there to get different types of fits. Let me do one small problem. A 20 mm shaft and the bearings are to be assembled with a clearance fit. The allowance is 0.002, tolerance on hole is 0.005 and tolerance on shaft is 0.003. Find the limit sizes of hole and shaft using hole basis as well as shaft basis system. First I am writing the given data. The basic size is 20 mm here and the allowance, which means the minimum clearance allowed is 0.002 mm. The hole tolerance is 0.005, shaft tolerance is 0.003. Now I am using a hole and shaft basis systems to identify the limit sizes of hole and shafts. So firstly I want to use a hole basis system. In the hole basis system, you see this is a zero line and this 0.05 is nothing but the hole tolerance, 0.03 is the shaft tolerance and 0.02 is the minimum clearance. Okay. Now using hole basis system, here the hole is kept constant. Okay, the shaft is only varying here, and here for the hole the upper size limit, this is the hole, this is the shaft. For this hole the upper size limit is nothing but this. Okay, so this 0.05 will be the maximum tolerance of that particular hole. So the basic size is 20 mm. Now upper size limit of the hole will be the basic size 20 plus this maximum tolerance 0.05. By adding these two, what we can able to get is the upper size limit of the hole. This is called upper size limit of the hole. Next, this will be the lower size limit of the hole. The lower size limit is nothing but it is equal to the zero line. So the basic size itself will be equal to the lower limit size of the hole. Coming to the shaft, this will be the upper limit, this will be the lower limit. Now coming to the shaft, upper limit will be this basic size minus this clearance. So 20 minus 0.02. 19.998 mm is the upper limit size. This will be the lower limit size of the shaft, the lower limit, which means 20 minus 0.02 minus 0.003. That is the lower limit size of the shaft, 19.995 mm, which we observed. Here we observed the upper and lower limit sizes of hole and shaft using hole basis system. Here this hole is kept constant, the shaft is only varying as per the given clearance. Like this we can find the upper and lower limit sizes. Now we'll do the same for shaft basis system also. See, shaft basis system. In the shaft basis system you see, so this is the zero line, this is shaft, this is hole. Here in the shaft based system, the shaft is kept constant and the hole is only going to be vary as per the given clearances or as per different types of fits. Now the shaft basis system for shaft. So this is shaft, this is hole. Let me identify the upper size limit for the shaft. This is the zero line. Now this will be the upper limit of the shaft, which is equal to the basic size. So upper limit size will be equal to 20 mm exactly. Now for the shaft, the lower limit size will be, this is the lower limit of the shaft, that will be 20 minus 0.03, which means 19.997 mm. Next, for the hole, this is hole, you know, a minimum clearance of 0.002 is there. For the hole, this will be the lower limit and this will be the upper limit. This is upper limit, this is lower. For the hole, the lower limit will be 20, this basic size plus 0.02. Upper limit will be 20 plus 0.002 plus 0.005. You see, the lower limit size will be this 20 plus 0.002. Upper limit will be this 20 plus 0.002 plus 0.005. It's 20.007 mm. For like this, we can able to identify the upper and lower limit sizes for hole and shaft using shaft and hole basis systems. Okay. Now, some of the activities or case studies or important facts related to this session are measurement of components. Just measure and classify various mechanical components which are existing in your surroundings and identify the fits and the tolerances present in that. And you see automotive engine design, you take any automotive engine design, there you try to analyze how the limits and fits are used in the design of engine components to ensure efficient operation and durability. Okay, so these are some of the case studies or activities you have to do. And also I took one aircraft manufacturing case study, investigate how the precise limits and fits are crucial in the assembly of aircraft components to ensure passenger safety and performance. These are some of the case studies which are mapped to this session, and the examples discuss how Apple uses the tight limits and fits in the design and assembly of its products for a seamless user experience, and also share a recent article about the 3D printing technology revolution limits and fits in the manufacturing industry. You take these two as examples for practice. And so far in this session we learned about the importance of fits and limits, and also we used to find the limit sizes of hole and shaft using a hole and shaft based systems for an example problem. Coming to self-assessment questions, what is the purpose of using limits and fits in the metrology? The answer is to define the acceptable tolerances for the two mating parts. Which term refers to the allowable deviation or difference between the dimensions of mating parts in a mechanical assembly? The answer is the term tolerance. These are some of the terminal questions mapped to this session. These are the textbooks and reference books we are suggesting to this particular session. Thank you very much.